the sum of a geometric series to an infinity. Now this rule is given to you in your formula book in the exam. So it says the sum of a geometric series to infinity is the sum to infinity is equal to a divided by 1 minus r. Now remember, a is the first term and r is the common ratio. There is one condition on the value of r. It must be between minus 1 and 1 to be finding the sum of a geometric series up to infinity. So we're asked to find the sums to infinity of the following series. We're asked to do it for 40, 10, 2.5 and 0.625. Like with all geometric sequence questions, when we're trying to find the sum of a geometric series, we must first identify the first value and the common ratio in a series. So the common ratio here is how do you get from 40 to the value 10? Well, to do that you need to multiply 40 by the value a quarter. So r must be equal to a quarter and a must be equal to 40. Now all we have to do is substitute these values into the equation. The sum to infinity is equal to a divided by 1 minus the value of r. So a is equal to 40 divided by 1 minus a quarter. Well, 1 minus a quarter is 3/4, so this is going to be 40 divided by 3/4, which is equal to 53.3 recurring. Right, let's have a look at one more example, this time where we're not actually told what the value of p is. So, well, we can identify the first term from just reading the series. Well, a is obviously equal to the value 1. But to find the value of r, we need to look at the second number in the series, so 1 over p, and divide it by the value for the first term, which is 1. So 1 over p divided by 1 is going to be equal to 1 over p. So this is the common ratio. Now, this can only happen, of course, providing that the value of p is greater than 1. Because if you had the value less than 1, if p was 0.5, 1 divided by 0.5 would be 2, which is not going to satisfy the rule in the equation given that r has to be between minus 1 and 1. But if p was equal to 2, 1 over 2 would be a half, so that's fine. So, let's substitute now our values into our equation. So, the sum to infinity is going to be equal to the first value divided by 1 minus 1 over p. Well, we need to figure out what is 1 minus 1 over p. So that's a little side over here. Let's just figure out what is 1 minus 1 over p. Well, if we convert 1 to p over p minus 1 over p, you'll find that you get p minus 1 over p. So the bottom part of our fraction here is going to be now equal to what we just found. So we're going to have 1 divided by p minus 1 over p. Now remember, when you're dividing by a fraction, you flip the second fraction and times it. So actually, if you sort this out, you end up with the sum to infinity is equal to p over p minus 1. And this formula, as I said, is given to you in your formula book in the exam, so please use it.